Thank you very much, Professor O'Connell, for talking with me today about your new book, Innovations and Renovations, Designing the Teaching Laboratory. This is a new title in the American Chemical Society Symposium series. First question I have for you is, why this book? Why now? Why you?
Sure. In the summer of 2011, we started to have some conversations in our department about renovating our general chemistry teaching labs. We did a feasibility study on renovating just a single lab room to see what the cost would be, what the timing would be. And as we continued to have these conversations, it became apparent to us that this was a project that really did need to happen. And I knew that the following summer in 2012, I would be attending a conference called the Biennial Conference on Chemical Education, which is an ACS, American Chemical Society sponsored conference. And I thought, well, why don't I submit a proposal for a symposium about teaching lab design? And I would hopefully be able to hear from other people who had recently been involved in renovation or construction projects and get ideas and information from them that would help us with our own project. And so the idea was accepted and the symposium was set up, and 6 people submitted papers that they presented in the symposium, and it was very helpful for me. And while I was at the conference, a representative from the ACS came to me and said, we think this would be a really good title for our symposium series books. Would you be interested in editing a book on this topic? And after giving it some thought, I agreed to take on that project. And so in the end, 4 of the people who had presented in the symposium each agreed to write a chapter for the book. And then I had to recruit a few more to sort of fill it out, and I recruited 6 other authors who each contributed a chapter. So it's a 10-chapter book.
Can you talk for a minute about the variety of projects that are represented in the book?
We got a wide variety of schools represented in the chapters. So we have small schools that are primarily undergraduate, liberal arts schools, up to large research universities, state schools. So in the small school category, we have things like Wheaton College or St. Olave's College, University of Iowa, University of Nebraska at Lincoln sort of typify the other end of that spectrum. There are differences there in terms of the kinds of instructors in laboratories, so it was good to get that variety. In a small school, it's primarily faculty who are in the labs with students, and in a larger school, it will be graduate student teaching assistants, and so there are different needs there. And we also have 2 chapters in the book that are written by architects from architectural firms that design teaching laboratories in multiple schools. So those are kind of nice overviews of different projects within one chapter. And our own architects from Payette, Robert Pazurski, who designed our laboratories, wrote the final chapter. And so they talk about the Mercury project within that chapter, as well as some of the other projects that they've worked on.
Can you tell me a little bit about the Mercury laboratory renovations?
So our Mercury project occurred for 2 main reasons. We wanted to update and upgrade the laboratories because they were showing some wear and tear from 20-plus years of use by students. Secondly, we also needed to accommodate large numbers of students. Over the past decade, we've seen increases in our science enrollment very steadily. And we had gotten to the point, at one point we even needed to add on a Friday evening lab period in order to accommodate all of the students who wanted to take general chemistry. And that was not a very popular lab period, as you can imagine, but some students, needed to be in that period because we just didn't have the space. So we wanted to increase the capacity at least a little bit if we were able to do that within the same footprint. And so the administration agreed with those reasons, that we should redo the laboratories. And so what we ended up doing was renovating our 3 general chemistry labs, and one of those 3 labs over the years had turned into sort of a flex lab. It was used not only for general chemistry, but also for analytical chemistry, which is an upper level course, and inorganic chemistry lab, depending on the semester. And so we needed one of the 3 rooms to be flexible for multiple courses. And so 2 of the labs got renovated and are dedicated just to general chemistry. And then the third lab is larger and is sort of our super flex lab and is used 1 day a week for general chemistry. And then it's also used 1 day a week for an honors general chemistry lab course that we have for a group of students that comes in very well prepared for chemistry. They go into sort of an accelerated lab course. And so that course is held in there 1 day a week. And then the rest of the week, it's used for either analytical in the fall or inorganic in the spring. So in the end, we did end up with a larger capacity in the general chem labs. The original labs were designed for 18 students each, and the 2 general chem labs now hold 20 students each. And then the third general chem lab was still only designed for 18 students. The big Superflex lab holds 24 students, so we were able to get a higher capacity in those labs. And also because the Flex Lab is designed specifically for those 2 courses or for those multiple courses, it has instrumentation area dedicated to analytical chemistry and inorganic, and we no longer have to sort of tear down analytical experiments in order to make room for general chem experiments and vice versa. So we can have general chemistry lab in there in the morning and then analytical lab in there in the afternoon, which was something we weren't able to do in the past. So we've increased our capacity even more than just by what's indicated by the numbers.
Can you tell us about the typical process of designing a laboratory renovation? And if you can tell us a little bit about the Boston College experience.
So I think our project was pretty typical. You start with a phase where you're just having conversations about what do we need in our laboratories? What are our curriculum needs? What physically do we want? What features do we want to have in the lab in order to be able to teach our curriculum effectively? This phase might involve outside consultants. So some of the chapters in the book talk about bringing in outside consultants to help with that phase. We didn't do that, but what I did was I gathered together a group of teaching assistants, about half a dozen TAs, and had a focus group, and we talked about what would have helped them, what features they would like that would be different from our old labs, or what in our old labs was working, and then what was not working, and what could be done better. So that's sort of the first phase. And then the capital planning and engineering folks do get involved in that phase, and then moving on to selecting architects. So we interviewed 3 architectural firms, and that was with people from capital planning and engineering. And we selected one of those 3 firms, Payette. And then you start to have your design phase in earnest with the architects, where you're sitting in meetings and people are throwing out ideas, and the architects drop plans and designs. You examine them, a lot of iterations back and forth during this phase of tweaking the designs. The people involved at that point are, of course, the architects. Engineers get involved. BR+A was the engineering firm that assisted us. The capital planning and engineering people are still involved. Representatives from chemistry were myself, our operations manager, Ian Parr, and Evan Kantrowitz, who was the chair of our space committee at the time. We were sort of the 3 main representatives from chemistry involved. Ken Metz, who runs our analytical and organic lab courses, and Christine Goldman, who does the honors general chemistry lab, were participating in some of those meetings as well to help with the Flex Lab design. So that continues for several months. And, you start with sort of schematic designs where it's just what's next to what, how many benches are you going to have, where are you going to put them, where are you going to put the fume hoods. And then it gets down into very detailed measurements. What kind of materials are you going to use? How many shelves? How many drawers? So, you sort of work your way to very detailed, finalized plans that everybody signs off on and approves. And they go out to bid to contractors. And we hired Wise Construction as our contractors. And they came in. So we're now into 2013, where they came in April of 2013 to begin construction. And it was important to us that the construction happened just in the summer so that we did not disrupt the academic year and the students taking the course in the academic year. So we did finish lab a couple weeks early in April so they could get started a little early, and they were finished by August 18th. And we were able to move back in and start labs up on the first day of classes in September. But throughout the summer, throughout the construction phase, you're having weekly meetings with the people from the contractor and with a project manager who's from our capital projects area, Paul Scarnisi in this case. And you're doing walkthroughs in the construction site to make sure things are getting done and things are in the right places. We also brought in people to help us with the AV equipment, the audiovisual. So an outside firm called Adtech did our projectors and everything that we needed for that area. People from network services come in to make sure you have the right number of drops and they're in the right place. So throughout the construction, there's a lot of people that need to be coordinated. And Paul, our project manager, was sort of the conduit that all the communication went through, and he did a great job keeping it on schedule and keeping everything organized. The sequence seems to be pretty typical. Some of the chapters in the book talk about projects that were much larger than ours. So we renovated just 3 general chemistry labs. Some of the chapters talk about entire science complexes that were built from scratch, including biology, chemistry, physics, whole buildings. So the sequence can be much longer. It can take place over a much longer time period. But I think the sequence of the phases is pretty similar from project to project.
Who is involved in the design phase of the process?
So in our project, I never really did bring students into the project. Ours was a pretty quick timeline. Other schools will have a couple of student representatives on their committees at that beginning, pre-design phase even, the phase where you're talking about what do we need in the lab. So I really use the TAs as my informing, the front lines, so to speak, of giving us feedback about what should be in the labs rather than the students.
What was the biggest improvement you saw as a result of the Mercury renovation?
I would say the biggest and most visible improvement in our labs that's also echoed in many of the chapters in the book is this idea of using the laboratory not only as a lab but as a classroom and improving the sight lines. So our old labs had individual fume hoods for every student. They were custom built. They were really quite innovative at the time. They had transparent sides, and every student had a little fume hood that they could work in. They had their own drawer of equipment and their own space on the lab bench. And we had benches with these fume hoods throughout the whole laboratory, the center of the lab, the edges of the lab. And it was very difficult for an instructor to stand anywhere in the room and see all the students. It was impossible. You had to constantly be on your feet, walking around, seeing how things were going. There was a blackboard in a corner of the laboratory where the TA could give a pre-lab talk. The students sort of crowded around the blackboard. They were just standing in between all these fume hoods. It was a very sort of fume hood dense construction model, and did not leave a lot of opportunity for teaching, and also not a lot of opportunity for students to work together. And this is a big trend in chemistry education, is cooperative learning. The older model in chemistry lab teaching is students work independently on an experiment. They're following very stepwise instructions to complete their experiment and probably verifying something that they've learned in class. We call these traditional verification experiments. The trend has been away from those and into more problem-based learning in the laboratory, where students are given a problem. They perhaps have to design some of their own procedures to solve that problem. We have something called guided inquiry, where as they're doing an experiment, they maybe have questions they have to answer along the way, perhaps even write down the answers, and that takes them to the next step of the experiment. That involves a lot of instructor interaction with the student. And so you have the necessity to have students work in groups to bounce ideas off of each other, to learn from each other, help ask each other questions and answer each other's questions. And so you move toward a more student-centered learning and away from the teacher-centered learning paradigm. Well, physically, you need a laboratory that allows students to interact with each other. And these models, like our old model and typified in many other institutions where you have these individual workstations and students can't see each other because there's maybe a shelf on top of the bench, or in our case, fume hoods, preventing them from looking across the bench at who they're working with. It's not very conducive toward this cooperative learning style. So what we did, and what many other schools have done, is we put all the fume hoods and sinks and that sort of infrastructure on the perimeter of the laboratory, so that the middle of the laboratory is where your benches are. So the benches are low, there's no shelves on them, and you can see toward a whiteboard in this case. We have lots of whiteboard space now for the TA to use, and sliding boards that they can write on. We have a screen with a projector so they can do a PowerPoint presentation. And in our labs, the center is, we call it a U. It's really two L's because there's sort of a break in the middle. And the students sit around this U in sort of a semicircle. The TA is in the middle at a podium, sort of a TA station. And so you can do much better teaching. The TA throughout the whole lab period has a clear view of every student and what every student is doing. And students can also see each other as well. In some of the schools, rather than having a U-shaped bench, they have actually tables, or even different shaped tables, octagons and that sort of thing. So students are sitting around a table and facing each other and able to be sort of clustered in this way, working together on projects. So I would say that's the biggest trend you see in teaching lab design right now, is the improved sight lines and the ability for students to sort of cluster and work together on problems. Another trend that we see in our labs that is shown in other chapters is the flexibility theme. So having labs that can can be used by other lab courses, but not only in terms of courses, but also flexibility in terms of teaching style or learning style. So one of the schools had lab benches that were actually mobile and could be moved around. So if somebody wanted sort of the cluster effect, put them into tables of, for 4 students, or it could be put into a U shape like we did, or it could be put into a whole, square or circle, so students are all facing each other. So actually putting lab benches on wheels is sort of an innovative design that is talked about in one of the chapters of the book. So flexibility is another theme that you see repeated in the chapters. Integrating the technology into the laboratory is also very important. In the 1990s, the innovation that came about was interfaces that allow students to collect data on the computer with probeware, so temperature probes, pH electrodes, that sort of thing. They can acquire the data, it's graphing it on the computer for them in real time. So pretty much every lab design needs to make some allowance for computers and these interfaces. The more recent innovation is allowing students to now share that data with each other through things like Apple TV, through projection on screens. One of the schools actually put in 6 large television screen monitors around the laboratory rather than having a single projection screen. And so each cluster of students is near a monitor, and every student has the ability to put their data up on those screens and share it with the whole class. And so you can have different groups working on different variables sort of thing and comparing their results. So technologically, that's sort of the biggest trend, I would say, in the designs, is sharing data with the whole class.
What about green chemistry and green building practices that are described in the chapters? Especially, there's some mention of leadership in energy and engineering design, or LEED practice.
Several of the chapters describe projects that received LEED, Leadership in Energy and Environmental Design certification. So 2 of the schools received a gold level certification, through that program, and one of the schools received platinum certification, which is the highest. So there were schools that were very actively trying to incorporate green principles in the construction of their laboratories. The one that received the platinum certification completely revamped their whole curriculum to use green chemistry in their curriculum. So you have green construction principles, and then you also have green chemistry principles. And so at St. Olave's, they've gone to a curriculum where in the laboratory they're using very non-hazardous chemicals so that they don't need all the safety controls like fume hoods. They aren't generating as much waste. When you're talking about lab construction, the least green aspect of it is the fume hood. Okay, I read in one of the chapters that a single fume hood running 24 hours requires as much energy as a home. So if you want to be green, you want to sort of reduce how many fume hoods you have, and you can do that if you turn to a green curriculum. So that's one way to do it. Another way is to use a different kind of fume hood. So some schools are looking at ductless fume hoods. So a typical fume hood brings in outside air to replace the air that's being taken away with the fumes. And you have to, of course, regulate that outside air to get it to the right temperature, and that requires quite a bit of energy. A ductless fume hood uses the air within the room to circulate through a filter, and so they're a little more energy efficient than the other kind. The other thing you can do, and that most of the schools seems to be doing, is putting the fume hoods on an on-off switch. People get a little bit nervous about that because of the safety aspect, but in a teaching lab, at the end of the lab period, all the chemicals are packed away, all the equipment is packed away into drawers, and the fume hoods are empty. So it's perfectly safe to turn off the hoods at the end of a lab period, and that's a huge savings, not to have the hoods running 24/7, especially over the vacation weeks and that sort of thing. So those are one way to attack the green aspect of construction. And other schools looked at alternate energy sources for their lab, geothermal or solar. And one school talked about replacing or using the material from the demolition for other things, recycling the material from the demolition. So all of these things help to certify you as a lead project. Related to the green aspects would also be safety considerations. And another theme that comes up in the chapters and that's reflected in our project was centralization of the preparation area. So every teaching lab has sort of a prep room where the chemicals are prepared and the solutions are made. And then chemicals have to go from the prep room out into the teaching labs. In our old labs, we had chemical storage rooms on one side of the hall. We had the prep room on the other side of the hall. We had carts of chemicals going from the prep room into the teaching labs. And it really took the architects to point out to us, this flow is not very good. It's not very safe. You have things going across the hall frequently. We'd like to centralize the prep area. And what they did was put it between the two general chemistry labs, and then they were able to install what we call pass-through fume hoods. And so a pass-through hood opens on both sides. It has a sash on either side of it. So in this case, one side is on the prep room side, and so our lab technician makes the chemicals and the solutions. He opens the sash, puts the chemicals in the pass-through hood, and then the other sash is on the general chemistry lab side. And so the TA simply lifts up the sash, and all the chemicals are there for the student. We're no longer taking things out into the hallway. The TA is not having to unpack and repack chemicals onto a cart, and it's really made things more efficient and more safe. So centralization of the prep, you see that in some of the other chapters as well. Actually, we learned of the idea of the pass-through hood from the University of New Hampshire, which we visited in our design phase. We went to 3 schools during the design phase who had recently renovated or constructed labs. We went to Brandeis, UNH, and Wheaton College here in Massachusetts. And so we got some really good ideas from those schools. And that actually is a typical step of the design process, is to visit other institutions, and you'll see that in other chapters of the book as well. Of going to visit other schools and getting ideas from them.
What were the biggest challenges of the Mercury project?
I would say, budget is always a challenge, and, staying within your budget. The timing can be a challenge. As I said, trying to keep that, in our case, into just the summer months was something that I think was a challenge for the contractors and that we had to keep on top of them with. And just coordinating everybody who needs to be involved in the process is a huge challenge. Letting everybody have a voice who needs to have a voice in it, and facilitating the communication between all the parties. We had many conference calls. There were certainly a lot of emails going back and forth. And as I said, Paul Scarnisi was very effective at keeping all that coordination happening during the construction phase and the design phase as well.
What were some of the most innovative projects you learned about in putting the book together?
So in the schools that did entire science complexes, which was different than our project, what I saw that I thought was very interesting was a real promotion of interdisciplinary features for the sciences. So instead of grouping scientists in the building by department, which is what you typically have, maybe a wing for chemistry, a wing for biology, a wing for physics, schools are now grouping them by sort of themes, interest area, and resources and functions that they share. For instance, if you have a chemist who is doing some environmental chemistry, and you have somebody in your geology department who's also working on similar issues, you position them near each other rather than keeping the chemist over here and the geologist over here. They share resources, they share instrumentation, and they have offices near each other so they can talk to each other and collaborate and exchange ideas. Maybe you have a biochemist who's really in the chemistry department and a microbiologist in the biology department who should be positioned near each other. So that I thought was very interesting to see the sort of walls between the science disciplines being almost physically torn down. And also making science very visible to the rest of the campus. There's a lot of talk in the chapters about windows to hallways, so students passing through the hallways can see what's going on in the science lab. There's talk of commons areas where students can gather, or faculty and faculty, or faculty and students, always promoting interactions between people in sort of informal settings in hallways or in corners of hallways. So that I thought was interesting. To talk about a couple of smaller innovations, there was one school who had a teaching laboratory that they use for their physical chemistry lab, but they also use it for a non-science majors course. It's a course about cooking and chemistry. Cooking and chemistry courses are not atypical. You find them in other schools, but this one decided they would make part of this laboratory food safe. Of course, you never eat in a laboratory, but they made a food safe area of the laboratory, so they put a little kitchen in, and they actually have their students doing experiments in the kitchen, and they can now taste their products. So I thought that was very forward-thinking of them. And the other one that I've already mentioned was the school that put the monitors around the perimeter of the classroom. They also included a flex camera for the teaching assistant. So if the teaching assistant is demonstrating a technique or an experiment, they can show a close-up of it to all the students using that flex camera. So those were some nifty little innovations I saw.
What has been the reaction to the Mercury renovations so far?
Okay, well, you're a little bit early to ask me that question. I did do a survey, a 10-question survey that I gave last spring to the last group of students who used our old labs. Questions like, I can see my instructor effectively, or I feel very cramped when I go to the balances, sort of agree and disagree questions. And I gave the same survey to the students in December, the first group who used our new labs. I don't have the results yet from the December survey, but that will tell us really kind of quantitatively what the reaction is. And that's been done at other schools, and you can read about that in the book as well. Some of the chapters include assessment studies like this, some much more rigorous than my 10-question survey. So that's something to take a look at in the book. Anecdotally, I would say that the reaction's been positive. My office was moved during this project. I used to be a few doors down from where I am now. I'm now much closer to the teaching labs, and I'm right outside of the first lab that you come to when you walk down the corridor. Now, the freshmen, they come from high school, and they had a lab in high school, and of course this is a better lab than their high school lab, and that's to be expected. So they don't have a lot to compare it with. But what I hear in the hallway is the upperclassmen, the sophomores, juniors, and seniors coming down the hall. They see this new color, because we put new colors in the foyers of the labs, and they take a look and they say, "Oh, wow, I wish I could have worked in this lab. I can't believe they redid this after I finished." So I would say, anecdotally, it's the older students look in and they can see the positives of the new laboratory. So hopefully it's doing what it needs to do, but we'll find out more details of that.